Hello, Toronto, and everyone else out there. Welcome, welcome. We are here tonight from the Allan I Carswell Observatory at York University, live with our Mars opposition event. So, those of you who have noticed, there is a mysterious red object up in the sky right now. It is very, very, very bright, and we're going to tell you all about it. So this event is running over several days here in October so that we get as many chances as possible of showing you some amazing views of Mars and maybe a couple other things as well through our 1 meter telescope on campus. That's the Allan I Carswell Observatory 1 meter. For a little Mars FAQ, we're pointed at our telescope, and to get started here, we have some fun facts. But first, let me just go ahead and say that this is a extension of our YouTube broadcasts or our Teletube broadcasts every Wednesday night here on this channel at 7:30 p.m. local time. So if you haven't had enough of astronomy fun, don't despair. Our regular broadcasts actually run every Wednesday, 7:30 p.m. local Toronto time. So I'm Dr. Hyde, and I'm here this evening with a whole cast and crew tonight. We have quite a few folks joining us. Tonight we have Obada, Quinton, Sunna, Kat, and Jesse, as well as Anna and Professor Paul Delaney over at the 1 meter telescope right now, running it for us. So welcome tonight. It has been a absolute blast watching Mars opposition get, as it were, closer and closer. So this, we're looking forward to telling you all kinds of great things about Mars and um, you know, all sorts of good stuff, but I just had to start with one quick question to anyone who is in chat or away, listening to us right now. So if you know the answer, feel free to type it in over on YouTube. If you go to outer space and head away from the sun, the first planet you would reach would be this red dusty one. What am I? So it's a riddle. I'll leave you all to think about that while we go ahead and get started here tonight. But Mars is very, very bright in the sky. It is actually one of the brightest things we can look at the moment. It is brighter than Sirius and brighter than Jupiter. It's also much brighter than the planet Saturn, which is also up right now. So just for a little aside and to get us, as I say, traveling through space here, we're going to do a little jumping around, and I'm actually going to pull through some live views of the telescope, just starting off with a little something different. So let me go ahead and pull that up now. And this is the current view through the 1 meter telescope at campus. As you can see, I actually have two cameras running here. And I'll go ahead and go first to the 1 meter telescope eyepiece cam. So Professor Delaney and Anna, I believe actually mostly Anna, have been loading these and pointing at Saturn. You can see that the eyepiece cam here, it seems to be jumping a little bit. And this is because this is the live image of Saturn through the eyepiece cam. So this is what you would see if we could get you all up into the dome right now to look at the planet Saturn. Saturn is very big, very fluffy. It is, as they say, the cuddliest and fluffiest of the planets. It is much, much larger and gassier than our dusky neighbor Mars, but it is also a really interesting location. And you can see that one of the first things that pops out here is, of course, those rings of Saturn. And you see the image jumping around a little bit. This is unfortunately due to what we call seeing, or as they say, clouds in the sky. So as the air in Earth's atmosphere wobbles about, the image through the eyepiece will actually jump, just like this, as you see here. And the way we point to these objects is by using our telescope control and actually pointing to what's called their right ascension and declination here at the telescope. And the telescope right now is aimed generally at the position of Saturn, and it's trying to follow Saturn as it appears to move across the sky from east to west. So this is a little bit of a little bit blurry jumping around due to atmosphere. However, if I could make this image stand still for a minute, um, we could try to get a little bit of a clearer view. So that's what we're going to do now, is actually move from our eyepiece view. So this is pretty much nearly live color, as it were. Um, and we can see that there is this nice yellowy color to Saturn. If I go ahead and switch to our CCD camera, so that's a charge coupled camera, it's still pulling the light in, but instead of having it pull in on real time, that image gets recorded in the same way that your phone kind of records an image for you. They also generally tend to use CCD cameras. So if I pull that across and just switch over to our other camera here, you can see that there is a much more static view of the planet Saturn. And this one, you can see a lot more detail in. So now I can start to see that there is really a bit of structure around the planet Saturn here. And now, Quentin, I believe you had a couple fun facts about Saturn.
Yes, I wanted to talk about Saturn's rings and the gaps between them. So the one interesting fact that I learned is that Saturn's rings, you may be able to see it in this image. Saturn's rings have gaps in them, the largest of which is known as the Cassini division. And the actual cause of these rings is a really interesting phenomenon called orbital resonance. So Saturn's rings consist of small chunks of ice and dust primarily. And as they orbit around Saturn, they're occasionally going to end up aligned with the larger objects that orbit Saturn, such as its moons. And the amount of time that it takes an object to orbit its host body depends on how far away it is. The further away that object is, the longer its orbit is obviously going to be. So if you are on an orbit that is aligned with the orbit of one of the moons, such that you keep passing each other at regular intervals, like for example, if you do 2 orbits for every 1 orbit of the moon, then that is what is referred to as a resonant orbit. Whenever there is a rational number between the number of orbits that one body does and the number of orbits that the other body does. So the Cassini division, any objects that would orbit within the Cassini division are on a 2-to-1 resonance with Saturn's moon Mimas, which means that they will go around. They'll go around twice, and they'll continue to meet up with Mimas in the same location. And every time they pass Mimas, every time they get close to it, they receive a little bit of a gravitational boost from Mimas's gravity. This will cause them to accelerate in their orbit and to move further away from Saturn because they're moving, because they are now moving faster. So over time, what this ends up doing is it ends up clearing this entire band of the ring system of all objects, because they continue to be given this gravitational boost at regular intervals, and this will eventually accelerate them out of their orbit. So the largest gap in the rings is, of course, the Cassini division. There are other gaps in the rings which correspond to other resonant orbits with other moons. And it's a very interesting effect. It's very much physics in motion.
Indeed, it's very, very nice to see Saturn popping through so well tonight. And as I say, it is a little hazy, so it does show up a little bit better on our CCD camera than it does on the eyepiece camera. And this is actually an interesting fun fact about the telescope as well, is because what we have is something called dual Nasmyth ports. That means that we can point the telescope in one direction and split the light in 2 ways. So if we split it one way, way, we send it to our CCD camera, and if we split it the other way, we send it to our eyepiece camera. And there's just a little mirror in there that will allow us to switch between which one we're pointed at. Now, since this is Saturn, I thought it might be interesting, or a little bit of a fun placeholder to mention. Saturn is much, much larger than Earth. Saturn is about 95 times the mass of Earth, and that really is quite substantial. That mass helps it hold on to its atmosphere. It's very, very thick, cloudy atmosphere, but it's actually very, very light and fluffy. So I said it's sort of the cuddliest of all the planets. It has a very low density. So what does that mean is that it would technically float in water, ignoring the fact, of course, that space is huge and the planet is huge, and there's no water that's big enough to float Saturn on. But the density is such that if you could take a little piece of Saturn, it would be less dense than water as we know it here on Earth. So, like all gas giants, its density does increase as you go further towards the core, but it's a bit funny because it's combined with its size and mass, the quote unquote surface gravity, or the gravity at what we kind of see as the surface, is actually just a little bit higher than Earth's. So it's a very funny, fluffy planet. Not just very pretty to look at, but also has a lot of interesting features. Of course, the ring systems and the moons of Saturn. Now, I believe we also have Jesse with us tonight. You have at one time said this was one of your favorite planets.
Yeah, well, the planet itself, yes, it's because I remember I got my eyes on it as one of the first projects that I did as an astronomy student in undergrad. And when I saw it through the eyepiece, it really blew my socks off because I couldn't believe that it was there. Like my eyes could see it. There they were. There were the rings that I saw in all the pictures from Hubble. And also, so that sort of memory really brings me back every time I see Saturn. I love this feeling, but there's so many interesting facts about Saturn. And I mean, that's true for all the planets, but even like when you think about, say, the surface features of Saturn, and so like the cloud features, it's so uniform across the entire cloud tops that took a really long time for us to figure out exactly how quickly it rotates, because the easiest way to measure a planet's rotation is to pick a feature on the surface or in the clouds and wait to see how long it goes around once. And that's just a simple way to do it. But Saturn is so flat, so to speak, that it's so difficult to calculate its actual rotation rate, its day. And that was only really fully nailed down with the work of Cassini in its final years. And so that's a really interesting fact. And not to mention that Saturn has the coolest moon in the entire solar system, the moon Titan, which is the only moon in the solar system that has an atmosphere. And I could go on and on and on and on about Titan. I named my cat Titan, for example. But there's just so much about Saturn that makes me love it so much. So that's just a small taste.
Absolutely. And yeah, so we might get into a little bit of an astronomer's argument here if we go to our next planet, Jupiter, because if we're going for the coolest moon, I know a few people who would absolutely fight you over Europa.
Bring it on.
But Titan is very special. So if you haven't heard of Titan before, it's a little bit of an aside today, because we're not going to spend too much time here on Saturn. But Titan is very, very interesting. It's the largest moon of Saturn. It's the second largest natural satellite. So it's the only moon with a dense atmosphere. It's the only other place in the solar system that we know of where there's clear evidence of stable bodies of surface liquid. That's stable all the time. So it's gravitationally rounded. It's got all kinds of interesting features. And if you want to find out more, have a look at the Cassini-Huygens mission. Jesse?
Dang, you just took it out. And even cooler, we landed on it. We landed on Titan. There are only like 7 places in the entire solar system that we've landed on. 6 maybe? I can't remember the exact number. And Titan is one of them. And the video, you can watch videos of the landing. Oh, I know we don't have time to linger on such awesome things like this because Mars is the star of the show. But if you don't know, if you've never heard of Titan or you want to learn more about Titan, Google Titan like crazy.
Yes, exactly. And if you want to count the number of things we've landed on, make sure you distinguish between landing and crashing.
Yes, good point. Very good point. Yep.
All right, so now that we're out in the icy parts of the outer solar system with Saturn and its fascinating moon Titan and its beautiful rings and its rather hefty mass, we're actually going to move closer and come in to Jupiter. So we're just going to move the telescope for everybody, and we're going to go from Saturn to Jupiter to Mars. So we're slowly coming in towards Earth. If you're following the look of the solar system. So Anna and Professor Delaney are right now changing our target to Jupiter, which you can see on the screen of the 1 meter telescope. So this is live happening now. So if you're watching on chat, this is real time. So just in case we mess anything up, you have a good reason. It's actually a real-time demo, as they say. So now you can see they've got the eyepiece cam hooked in, and the eyepiece cam also has different brightness settings we can choose, but we can see Jupiter coming into view right away on the eyepiece cam, and that's because the eyepiece cam doesn't need any exposure time or readout. It just shows you what you would see through the eyepiece right away. So this is one of our favorite ways to look at planets. And this is the planet Jupiter. So we're increasing in mass quite a bit here. And we'll go ahead and look at Jupiter and see if we can see some of the, of course, interesting structures on Jupiter, as well as possibly looking a bit at its moon. And we're just going to move Jupiter, first of all, a little bit into the center of our field. I don't know if you can quite tell, but we're a little what's called off center at the moment. So sometimes when we point the telescope, it's the object we want to look at isn't exactly in the middle of our field of view. So what happens is we use a little joystick paddle, which is actually looks a lot like a video game controller, to very, very slightly shift around the telescope until we line up our field of view and our object so that it's nice and centered. And here you can see we've got Anna, who is trying to center Jupiter just a bit and bring it back into that field of view. We can see the cloud bands coming through nicely here. And we'll just work on getting it just a tiny bit more centered for everybody. But I figure this is a little bit of action astronomy. The screen you see being pulled up on the side is the RA and deck. So you can see they're moving back and forth between object selection and actually finding the object itself. So that is the planet Jupiter. All right.
This is one of the things that I like people to see. Is the sort of behind the scenes stuff that happens. I mean, when you get your first telescope, usually it's a small one, something like, or even maybe you have a pair of binoculars and that would be your first quote unquote telescope. And for that, it's as simple as pointing at the thing you want to look at and then looking through the eyepiece. And as you graduate into larger, more complicated systems, the setup and movement and timing and changing gets more and more complicated as well. So if you're just like a budding astronomer and you want to get your eyes on something and you want to see the moon or you want to see Jupiter, you start simple. And then when you start wanting to take cool pictures and start investigating deeper, you get bigger and better and awesome stuff like this. But it can get quite complicated. What you're seeing on the screen here is just a nice demonstration of what it looks like for someone sitting at the computer, directing the telescope around, taking images. Oh, look at it. It's coming in perfect now. Look at that beautiful Jupiter.
Exactly. And we do have there was a bit of haze out, so that has apparently cleared up just a bit. And now we're seeing very, very clearly the bands of Jupiter. And it's just worth mentioning, so Jupiter is closer to Earth than Saturn. So Saturn orbits farther out. We've moved a little closer. Jupiter is also much, much more massive. So I said in terms of masses of the Earth, it would take actually 318 Earths to be be one Jupiter. So it's very, very, very massive. It's sometimes referred to as a failed star because of its, if it was only a few more times bigger, it could be fusing, several times bigger. Now, this planet is interestingly, it physically it's not a terribly different size from Saturn. So it is what we call not very cuddly. It is not very fluffy.
That's a
Yeah.
definition that you'll find in a textbook.
This is my textbook definition. It has quite a strong radiation field around it. It's very dense. It's very massive. It does a lot of work. It's the biggest planet in the solar system. So, not cuddly would be my official astronomical definition. So, Quentin, I believe you have a little bit that you like to talk about for the Great Red Spot.
Yes, the Great Red Spot. The Great Red Spot is, of course, probably the most famous storm in the solar system. The Great Red Spot is, of course, a very prominent feature on Jupiter that is it's a very large whirlwind, very large storm that is essentially that has been raging on Jupiter's surface since as long as we've been able to take detailed images of it. So for a very long time, much longer than any Earth storms have been able to maintain themselves. And it's also very large. The Great Red Spot is, in fact, larger than the Earth is. The Earth would fit inside this storm entirely. But that said, just because it's big and just because it's ancient doesn't mean it's eternal. And the Great Red Spot has shrunk significantly since we've been able to take images of it. Since the 1970s, we can actually examine footage of Jupiter from the 1970s and see that the Great Red Spot is not as large as it used to be. The Great Red Spot used to be about the size of 3 Earths. Now it's about the size of 1 Earth. And it stands as a bit of a stark reminder that no storm, not even one as mighty as the Great Red Spot, is eternal. There is going to come a day when that storm is going to calm down and die off, and we won't be able to see it anymore, as tragic as it is.
Indeed. And speaking of getting rid of the Great Red Spot, one thing we can do with an eyepiece cam is actually increase the brightness coming through just a little bit to bring out the moons. Now, I believe there is a good way to track the position of moons. Obada, you had one up earlier.
Yeah, actually, I had my astronomy software open and I was tracking the orbits of the moons. So right there on the left of Jupiter is Europa, which actually just completed its orbit from behind Jupiter. And Europa actually is my favorite moon in the solar system.
So Europa is actually the one that appears closest at the moment.
Yes, Europa is the closest moon from Jupiter. And to the left there, to the right, sorry, is Io, which Io actually is a volcanic planet. So it's full of volcanic plumes, and it's just a very hot planet.
Yeah, so the Jupiter's Galilean moons, I suppose we should give a little bit of a shout out to. So there are many, many moons around Jupiter. We have, I believe, something like 70 moons and counting. There's currently a bit of a contest between who can have the most moons. Is it going to be Saturn, or is it going to be Jupiter? And the more they count, the more they find. Maybe 79, but yes, the 4 most famous moons are the Galilean moons, and these are the 4 largest moons, easily candidates for favorite moon if you're not already completely addicted to Titan. But the moons of Jupiter are interesting because of their size and their characteristics. So you have, of course, Io, Europa, Ganymede, and Callisto, which are all large enough to have circularized. And Io, being the first one in, has the most volcanic action because it sort of has the highest amount of tidal forces on its surface. It's kind of basically looks like a bit of a pizza with all the volcanic activity, and the particles thrown up are thought to sort of participate, shall we say, in the high radiation field that is out there around Jupiter. And then, of course, you have Europa, Ganymede, and Callisto, which are all icy and, basically thought to have water or possibly oceans, especially Europa. Very, very fun. So this is identified by Obada. And just out of curiosity, what was the app you're using on that?
I was using Stellarium.
Excellent. So Stellarium would be the way to go. And that's Europa on the left and Io on the right. So this is, 3 dimensions of space, and we're, of course, seeing it from an angle. So they're not always exactly where we might think they would be, which is an interesting effect. Jesse?
One of the things that I find really, so you're looking at this image now, we have Jupiter that's washed out right now because we're overexposing to look at the moons, and you can see the little dots that are the moons, and those are great. They're like, what's really cool about this though, is you can look back way back to the images that were hand drawn by Galileo in the early 1600s, tracking the movements of those little dots. So imagine taking a picture, having this picture just like this right here, and then in a journal, you got a piece of paper beside you, drawing the circle that is Jupiter, and then drawing the locations of those dots that you see, and then going back night after night after night, or staying there all night and watching those little dots move and trying to ascertain how those little dots move in relation to the bigger object that is Jupiter. And you can go back and you can actually see Galileo's notes on this. You can Google Galileo's observations of Jupiter, and you'll find some really cool hand-drawn images of those little dots that you're looking at right here. It's a real cool connection to an ancient scientist, I think.
Absolutely. And, this is actually worth mentioning as well because of the speeds of the orbit. If you do have a small telescope and you would like to watch something go around, this is absolutely the perfect thing one of the perfect things to watch, because you can track it, you can journal it, you can confirm the orbits, all that good stuff. So looks like we've actually got a third moon off to the side here. Yep. So we've got Jupiter, 3 Galilean moons. And Obada was just saying, you were just saying that was Ganymede down here?
Yes, that's Ganymede. And just for some quick trivia, Ganymede is the largest moon in the solar system, and it's the furthest out from Jupiter.
Yes, and it is very interesting. Of course, those of us familiar with our science fiction might be hoping for Ganymede sea rats, but as of yet, we have not, in fact, landed there. So we're not totally sure what might be in the water for Ganymede or Europa. All right, so it is about time to head over to our main object. So still coming in through the solar system as we were flying on our space telescope here, we will head over to Mars. Now, as the telescope is moving, and we're going to have to give Paul and Anna a bit of time to go out and check the dome as well. You can see they are queuing up Mars. But in the meantime, we have a couple interesting Mars facts, which I'll just queue up here for you as well. Now, we obviously have been watching Mars for a little while. Tonight, we have high hopes of what we might see. But of course, we have had a couple of views along the way. And because Mars is so bright right now, one of the first things people might ask is, well, why is opposition a good time to view Mars? Why should we go and look at Mars right now? And it's okay, Mars is bright, but why should we look at it? Well, just to give you a little bit of a reference from Astronomy Picture of the Day, this is basically the reason why we're so excited to see Mars now. When Mars is in opposition, this means that it is on directly the other side of Earth from the sun. And we'll talk about that, I think, a little bit more today as well. But what this means is that Mars is also nearly as close as it can get. So if it's closer, it appears bigger. If it appears bigger, we can see more detail. So this astronomy picture of the day was a compilation done of Mars on different days approaching opposition. So today is the official opposition of Mars. Probably should have said that a bit sooner. But this opposition event, it'll be great all week. So we will keep on going all the way through the 15th. But why we're looking at it and why we're so interested to look at it is because as the Mars becomes larger and larger through our telescopes, we can make out more of these little tiny features. So it does get quite a bit better with time. So, what have we been able to see so far, you may ask? Well, during our online public viewing, if you were in that session, we do online public viewing every Monday on Zoom, actually. That was October 5th, and we saw Mars with the face of Syrtis Major visible. So, this dark splotch in the center is the Syrtis Major region. And when we came back a few days later on October 11th, we actually had Mare Serenum and Mare Cimmerium visible. So just like Jupiter and just like Saturn, Mars rotates around as well. And if we can watch it hour to hour, we can actually see different features on the surface of Mars. So if we could stay up all night, we would be able to watch Mars rotate. We won't be here all night, unfortunately. We'll just be here until 10. But hopefully tonight we will be adding to our collection of Mars face images, and these were both taken, just so you know, through the eyepiece cam. So these were not CCD images. These were eyepiece images. So as we were saying, Mars is very, very bright right now, and it is in the sky. So if you are outside, anywhere in, I guess, North America, look uppity, look up and to the left if you're facing south. So in the east right now, Mars is rising. It is bright. It is red. It is very, very hard to miss. If you like to track your spatial coordinates based off of constellations, it's towards the constellation Pisces. It is visible magnitude about 2.7, 2.5. There's a little hand waviness there, of course, because around opposition, it has a brightest and it sort of peaks down from there. But it is brighter than the star Sirius. It is brighter than Jupiter. So we were just at Jupiter talking about how many hundreds of Earths could go in there. Mars is just 0.11 of an Earth mass. It is tiny, so much tinier, but it is going to appear brighter than Jupiter because of its closeness. So that's October 13th, 2020. We are, at opposition. So we have this wonderful Mars right next to us. So if you kind of picture it a little bit like we're race cars on a track, then Mars is on the outer track racing past us, and we're just getting that closest approach. It's actually close to the planet Uranus, which we could try to go see as well, but Uranus is not particularly fabulous. It's a little bit of a dot. So if we weren't running just a Mars event, we might try to go to Uranus as well. So Mars rises around 7:30, so it's a little bit, just up from the eastern direction right now. And it is absolutely fabulous to see. So just keep in mind that even if you just come out and look with your naked eye, you'll be able to see that bright shining light. And just as a little reminder, if you're looking at finding a planet like Mars or Jupiter or Saturn or any of the other planets we've been talking about, planets don't twinkle. So planets don't twinkle. So if you're looking up at the sky, stars will appear to twinkle because the light has been traveling for what seems like infinity. And if that seems like a strange thing to say, just recall that optics, if your light is coming from what looks like infinity, it will focus a certain way. And so the light from planets like Mars only travels a few millions of kilometers instead of light years. So they're closer and there's a lot more of the light. So it passes more easily through our atmosphere. It doesn't get bounced around as much. It will get bounced around if there's clouds and haze, but point sources of light are really prone to distortion, that fluctuating around, bouncing around the air in our atmosphere. So they're not as steady. They appear to twinkle. It is quite fun. So if you're up there and you're not quite sure, is it a planet or Is it a star? If it's twinkling, it's probably a star. So the times to view Mars, if you're in Toronto like we are, have a look right now. If you're anywhere in North America looking east around 7 p.m., you'll catch it somewhere. um, and it's about 15 degrees above the horizon or so. You can use your arm to estimate degrees, just in case you're wondering. We were doing this in my astronomy class earlier, but your zenith is the point overhead, which is 90 degrees. And then if you go measure up from the horizon just by kind of pointing your arm, you could sometimes get an estimate of about how many degrees up something is. So don't worry if this all seems like a challenge. It is not meant to be. Mars is so bright and so red, should be pretty obvious. Even in downtown Toronto, you will be able to see it. So it's worth noting that Mars, it's rising just after sunset, and it sets just before sunrise. So it rises in the east and sets in the west, and it's on the opposite side of the sun. So that's not an accident. So that is actually due to opposition that we see Mars rising as the sun sets. It is physically on the other side of Earth, and that is part of the sort of the definition of opposition. So I'm just going to put that slide up real quickly here. So just so you can get a little bit of a better picture what I was talking about with the racetracks, of course, Mars being on the opposite side from the sun as Earth means that it's just on that outer track going past us. Obviously, this image is not to scale, so neither planet is to scale of size or distance, but it shows approximately what's happening with Mars, the Earth, and the Sun. So you have the Sun on one side, we have Mars on the other side. So that sunlight is directly hitting Mars, and we're seeing a beautiful, full illuminated Mars face, very, very close to us. So it's kind of like if you hold a flashlight right up to your face, you're going to see it as very, very bright. It is quite a sight, shall we say? So we will try to go there shortly. As I say, the crew is moving the telescope now. And we have some fun little Mars facts to get started with. Now, Kat, I believe you wanted to cover a little bit about Mars.
Indeed, I did. Oops, sorry. So it was just going to be about opposition in general, just to like get a taste as to what we're dealing with tonight. So I believe that would be slide 10.
Oh, all right. Opposition in general.
Yep,
Here we go.
Perfect. Thank you. So to brief, an opposition occurs when the sun and Mars are on either side of the Earth, such that as soon as the sun rises in the east, Mars will set in the west conversely. Since these two events happen at the same time, we dub it opposition, as they directly oppose one another. Normally, opposition occurs once every 15 to 17 years, occurring within a few weeks of Mars's perihelion, or perihelic opposition, the point where it is closest to the sun along its elliptical orbit. So some perihelic oppositions bring us closer to Mars than other oppositions. It can also be noted that the elliptical orbit of Mars has become gradually more elongated over the past few millennia, which brings Mars even closer towards the sun at the perihelion. So in short, what does this mean for future oppositions? Earth and Mars will be closer than ever before.
Excellent. And that is quite right. It is very, very close right now. The closest it's been since 2003, and the closest it will be until something 35. So the next 15 years or so. So as they say, don't sleep on this one. It's not going to get this good for another 15 years. And Mars comes by and will have a kind of an opposition every 2 years or so, but it doesn't get really, really, really close until the orbits actually really match up. And that's because also Mars's orbit is not quite as circular as Earth's. So you could actually see that up here in this distorted diagram where they've really accentuated the differences between Mars and Earth's orbit. And this is actually why we, just a few months ago, in this year of 2020, had 3 different fabulous space missions all launching on their way to Mars, because everybody wants to take advantage of this shorter distance for their spacecraft to travel. So So if you were to launch your spacecraft as we are here, you could see that, oh, okay, well, my spacecraft only has to go this little distance instead of all the way around. So it is quite a savings on fuel and time to get Mars to show up, if you can. All right. So Quentin, you actually had a little bit of a different Mars fun fact you wanted to run. I believe you were looking at talking just really quickly about the surface of Mars.
Yes. In the early space age, scientists thought that Mars was just like the moon. And during all flyby missions, all spacecraft coincidentally imaged the craters of Mars, which led people to believe that Mars had a similar environment to the moon. However, further research proved that there were dormant volcanoes that sat on the surface, which changed our view of the planet forever. There are pieces of Mars on Earth. Over many years, pieces of the Martian surface have landed on Earth, allowing scientists to study Mars without having to set foot on it. The three most common types found are shirkatite, knocklite, and chasignite. Shirkatite is a volcanic rock rich with magnesium and iron. Knocklite is also a volcanic rock, but generally formed a lot older than shirkatite and is rich with the material augite. Chasignite, made almost exclusively of the mineral olivine, contains noble gases different from the composition of the Martian atmosphere, which suggests that they are formed in the mantle. Mars was previously believed to have held intelligent life. We would still like to believe it did, but we just don't have any evidence for that. The Italian astronomer Giovanni Schiaparelli had thought that he had discovered canals on the Martian surface, but it was later proved that these were actually just naturally occurring features. The difference is that canals refer to artificially made structures, while channels, which is what they truly were simply a part of the natural landscape. It's also believed that complicating this observation was an optical illusion that can cause people to believe that they are seeing straight lines when in fact what they're actually seeing are points such as craters or surface features on Mars that the eye tends to naturally connect, especially when viewed through a not very clear telescope. Since this was around the turn of the 20th century, the telescope technology that was available at the time was not to the same standard that we have today. So unfortunately, there is no evidence that Mars currently has or has ever had intelligent life, as delightful as that would be.
Indeed, we'll just have to go there and then we'll know for sure. All right, let me just check the telescope real quick. It looks like we have Mars. So as you can see, we're talking about not too blurry, not too clear images. So we can see that the atmosphere is distorting our picture of Mars right now. We can make out some features, but just as Quentin was saying, gosh, if you watched this for long enough, you might just be convinced there was something really funny going on. So this is through our 1 meter telescope, and this is the eyepiece cam. And let's just go ahead and shift this over. This is our 1 meter telescope control, and we've got our Mars coming through with a bit of jumpiness from the atmosphere. So congratulations to Professor Delaney and Anna for pulling this up. They've obviously gotten the telescope dome turned around, and we are still a little low in the horizon, so we might be subject to a bit of atmosphere, as they say. But one of the things that does show up right away, although this is a little blurry of an image, this does not look like the other images we saw before. So we must be seeing a different face of Mars, or a different part of Mars. So I'll just go ahead and give a little shout out to the Mars Profiler, which is actually a really nice way to go ahead and track what parts of Mars are visible at the moment. So if I go ahead and put in, let's see, my date and time. I believe we're about 45 minutes out of UT. This is the Mars Profiler, which I'll just put onto this side. So this is Sky and Telescope Mars Profiler, which tries to show you what parts of Mars are currently visible. So what parts of Mars are visible at the moment? We haven't talked too much about the features, but we have Mare Serenum and Mare Cimmerium here, and a little bit of the Mare Tyrrhenum. So one of the things that came out before was we were looking at Syrtis Major. That is not the case. So we definitely don't have that side of the planet anymore. It is rotated away from us. The area that's quite bright, that is probably Amazonas. And these dark features are called albedo regions. And as you can see Mars in the background sort of jumping and twisting, you could imagine that if you were up all night watching this for hours and hours, you might think, oh gosh, this is probably like some sort of major, I don't know, Great Wall of Mars, or some sort of, man-made feature, or it's actually just a marble that's turned on its side. So people's minds do tend to draw lines and networks where there might not be any. And if you were really looking into the shadows here, as the image jumps around in our atmosphere, those shadows do tend to move and sometimes even look a little bit liney. So you can kind of make it out here. With this amount of jumping, we don't really have a good chance to see the polar caps, unfortunately. The polar caps would be just on the edge of Mars because they're, of course, at the poles, and being slightly pointed away from us, as you can see with the profiler. We would only get a little bit of the cap visible, and it looks like we're just losing due to that atmospheric disturbances at the moment. Okay, so this is where Mars is now, and we've seen where it was. Now let me just go back over here, and we'll look at one of the extra features on Mars. Kat, you wanted to talk about a few Mars fun facts?
I did indeed. So Mars is quite the interesting planet, not only because it could be our future home, and here is why. Did you know that its red color due to oxidized iron reminded people of blood, hence it being this namesake of Mars, the Roman god of war, as we all know. Not only that, but the god's varying temper was brought to mind when they saw the planet's dramatic variance in brightness over time due to its distance from Earth. So Mars, like many other planets in our solar system, they have natural satellites orbiting it. So it would be Phobos and Deimos, which are Mars's two moons, named for the sons of the Roman god Mars and his Greek equivalent Ares. They were found within a span of 7 days by Asaph Hall, Deimos, the night after he nearly quit his search. These moons are suspected to have been asteroids captured by Mars's gravity. Both with little mass, small enough to not have a large gravitational force to round off the moons, Phobos is actually falling towards Mars, gradually, of course, and will either break into pieces or collide with its host planet in 50 million years. Once this occurs, Mars may gather the particles and form its own ring, similar to other planets nearby, the most obvious of which is Saturn, as we previously spoke on. One other interesting fact about Mars is that just less than half of humanity's missions to the red planet have actually been successful. However, they have grown increasingly effective and successful, proving the importance of patience, dedication, and yes, perseverance.
Excellent. And this is Perseverance is one of the 3 missions on its way over to Mars at the moment. Hopefully, all of them make it, and we'll have even more beautiful pictures of close-up Mars, because nothing quite beats a satellite in orbit. As much as we might hope that as much as we might hope that our 1 meter could someday pull out, the details of Valles Marineris. We won't quite be able to get there, especially with the seeing. Now, we do still have a little bit of a wobble coming through. Now, I'd just like everybody in the live video to please try to remember exactly what these features look like. Because as we watch Mars over the next hour and a bit of change, these will slowly change. So every hour Mars rotates, so just like Earth rotates, it rotates around its axis. So it has a day very similar to Earth's day. And if you're very, very careful at watching, in about an hour's time, you'll just be able to see Syrtis Major poking out of the side, whereas now we clearly do not see where it is. Alrighty. So let me just go back here. Now, Obada, you were going to talk about the volcano, which we have not mentioned nearly enough, scandalously.
So yeah, this volcano is Olympus Mons, and it's my favorite feature, and it's probably the most popular one. Olympus Mons is an extremely large shield volcano and the tallest mountain in the solar system. Its height from base level is 21 kilometers, making it 2.5 times the height of Mount Everest. It encompasses an area roughly the size of the state of Arizona and is easily visible from the Earth. There are several reasons why this volcano is much larger than anything on our planet. The most obvious answer is the lack of gravity, allowing structures to keep growing beyond their collapse height. Another reason is due to the lack of tectonic plates on Mars. The reasons why volcanoes grow is due to the fact that hot magma is pouring out from the inner parts of the planet. On Earth, these plumes move relative to the plates, causing a more scattered mountain formation, like the chains of Hawaii. On Mars, these plumes keep growing and spewing out magma in the same spot, which allows volcanoes, like Olympus Mons, to grow so tall and wide.
Very nice. And of course, Olympus Mons is an absolutely enormous volcano. We are not quite able to make it out tonight, unfortunately. It is just off the northwestern edge of what's called the Tharsis Bulge, next to the Amazonas quadrangle, which is where Amazonas Planitia is. And we're currently just on the edge of Amazonas. So I'll just go ahead and bring that back up again. Just in case you were wondering where this moon might, or sorry, where this where this volcano might be in terms of our little image. Now, here's Amazonas on our Mars profiler for tonight. Let me just reset to current date and time. There we go. And our Tharsis Ridge would be kind of in the middle-ish here. And so if you can kind of imagine that will be down in our brighter area of Mars. And we are kind of seeing it at this angle here. So much like everything in space, everything's at an angle and everything's tilted. But if we were looking for the Olympus Mons, it would just be inside this Amazonas region, which would be just to sort of the south of the dark Mara features, and right in the middle of the kind of the brightest bit of the bright red regions that we're seeing here. So you've got your dark albedo features and your light albedo features. So this is a light albedo feature, which was kind of matching the general location. So despite the atmosphere jumping about a bit, we can tell approximately where it would be, but I would challenge anyone's eyesight to be able to actually distinguish the point of the Olympus Mons in this image. We might have there may be some among us who think they can see it, but it's definitely not me. So, and just as a little reminder, as we are about halfway through, if you have questions today, feel free to ask them over in the chat, and we will try to get to as many of them as we can. So there was a question earlier that I missed. Apologies for that. about the source of the radiation on Jupiter, and that's actually a lot to do with Jupiter's magnetic fields. So one of the interesting things about Mars is actually its lack of a magnetic field, which we might have time to talk about later. Um, so it looks like after a little bit of side consulting with the crew here, we have all agreed that we do not, in fact, we do not see Olympus Mons. So we voted, and it's definitely not there, not visible at the moment. Okay, so now next up, we're going to talk a little bit about, let's see, we had a quick aside from Quinton, who is going to take us over to a little bit of a different Mars fun fact.
Hello. So we have some really interesting facts about Mars. Mars has huge dust storms that can cover the entire planet for several months. So a theory as to why this occurs is because airborne dust particles will absorb heat from the sun, which will create pockets of warm air, and then that warm air will move towards colder regions, and in the process of doing so generate winds. And these winds kick up more dust particles, and the cycle continues. So you can actually see when Mars's surface is obscured by dust. It actually becomes very difficult to view the surface features at this time. Also, Mars's tilt swings wildly over time, unlike Earth's, which tends to stay at an average of 23.5 degrees, at least over shorter time scales. The reason is because Mars doesn't have a large enough moon to stabilize it, unlike ours. Earth's moon is actually, of all of the planets in the solar system, Earth's moon is the largest in comparison to its host body. So it isn't the largest moon. That honor, of course, goes to Ganymede. But compared to the Earth, our moon is very, very large. And this is one of many things that sets Earth apart from other rocky planets. It's actually quite rare for rocky planets in general to have moons. Venus and Mercury do not have moons. And Mars's moons are essentially just captured asteroids from the asteroid belt. Mars currently has no magnetic field, as Professor Hyde was mentioning. However, there are regions on Mars that have at least 10 times the magnitude of any magnetic field measured on Earth. So in overall, there is no magnetic field on Mars, but there are regions that have a very strong local field. And this hints at the possibility of an ancient magnetic field, because we believe that what might have caused this is a magnetic field which used to exist could have magnetized the iron in Mars's surface or beneath the surface at some point, and that would have preserved the magnetic field in that region even as the overall magnetic field went away. Another interesting fact, blueberries, quote unquote, were recently found on Mars. These aren't, of course, the blueberries we know, but instead iron-rich spheres found near the landing site of NASA's Opportunity rover. They indicate that Mars was once incredibly wet, flowing with a lot of liquid water. And that's because these blueberries are primarily made of a compound called hematite, which tends to form in very wet areas.
Indeed, and I'll just go ahead and put up our little hematite FAQ as well, since we're on it. Hematite is a very interesting mineral that we actually are quite familiar with here on Earth as well. So in the solar system, it's always worth remembering that these planets are so different. We try to make generalizations about how things work, but Mars is such a fundamentally different planet from Earth. It's low mass, it's different properties. Earth is so weird. It had that giant collision which formed the moon. It's really, we could say that every planet in our solar system is a little bit bizarre somehow, if you think about it. But hematite is actually something that we think we understand fairly well. This is one of the reasons why people got so excited about it when they found it on Mars in a form they recognized. So hematite, this mineral, can carry magnetic signatures. It's preserved in rapidly cooling volcanic rocks, and its color actually can add to that reddish color of Mars. It is often formed in a standing wet environment or standing water on Earth, and one of the ways we know we can form hematite on Earth is in wet standing environments, and it creates hematite spheres. And it wasn't just any kind of hematite we found on Mars, it was actually hematite spheres. So people saw that and they were just absolutely floored, because this is a process with a mineral that we think we understand quite well here on Earth, but not just in any form, in the form that it is known to have in standing water type environments. So this was very, very, very exciting. All right. So next up, we have a quick little aside. Sunna actually wanted to bring us back to some of the bigger features on Mars. Let's see, I believe this is actually one of arguably the biggest feature on Mars and the biggest one of its kind. Go ahead, Sunna.
Yes, so this has actually got to be one of my favorite features on Mars because it's so interesting. It's one of the biggest features not only on Mars, but I believe in the solar system, which is the Valles Marineris. So the Valles Marineris, which is Latin for Mariner Valleys, which was named after the Mariner 9 orbiter credited for its discovery, is a massive canyon formation near Mars's equator. This canyon system is one of the largest canyon systems in the solar system, and it covers an area on Mars's surface almost the size of the USA. The Valles Marineris stretches over 4,000 kilometers long, it's 200 kilometers wide, and about 8 kilometers deep. So to compare, the Grand Canyon's maximum depth is about 1.8 kilometers. And if you think about the size difference between Mars and the Earth, this is absolutely massive. There are several theories as to how the Valles Marineris formed, including plate tectonics or volcanic activity during the early days of Mars's formation, which were then followed by landslides and further volcanic activity that widened and deepened the trench. The image on the left of the slide is a mosaic image compiled from the Viking 1 orbiter mission, which shows just how much of Mars's surface the canyon covers. And on the top right, there's a more detailed image of the Valles Marineris, which was also taken by Viking 1. And then the bottom right image shows a topographic view of the valley.
Very, very nice. And like you say, this is one of this most impressive sort of features that we know of. It's, it would stretch across the entirety of the width of Canada were it allowed to. And it's some sort of, thought to be even a kind of a tectonic crack in the actual crust of Mars. So Mars doesn't do anything small. It is a tiny planet, but it does everything quite large. And this Valles Marineris, it goes across what's called the east side of the Tharsis Bulge. So just to go back and have a quick little look here. I think we're actually changing to the CCD. I'll go back and put up my profiler. We're just going to see if we can get a slightly higher resolution image. But if I look at where we are now, if I go east of this Amazonas in the middle, that's going to put me around the Elysium area. And if I go west across that same area, that'll put me off. So that's the side of the planet that we couldn't currently see. So the Valles Marineris is sort of along the equator, sort of in this middle part of Mars. Mars does have a tilt to its orbit, so of course this is all tilted as is Earth. So that equator area can sometimes appear at a bit of an angle. Now, because we have this large valley, what we'd be looking for is kind of a darkish line starting in the west and then proceeding off east across the equator region of Mars. Now, we didn't quite make that out here because it is a very sort of much more subtle feature than the large mare what we're calling those albedo features before. But it is something that if you have high enough resolution, you can just about make out. It's quite a big valley, as they say. So we'll keep an eye out for that. I think in about an hour we might have a little bit better seeing as well. So good to keep an eye out. Now let's hop up here, and we had a couple extra little interesting things to say about Mars just in general. And Jesse, you had a little comment?
Yes, so we just finished talking about Valles Marineris and the Tharsis Bulge a little earlier, and Olympus Mons that goes with it. And what is really, I really like the story of how all of that's tied together, and it's been hinted at and talked about. And when you compare Earth to Mars, one of the many differences is our very successful plate tectonics and internal heating and volcanic activity. And the crust of Earth is this patchwork of plates that float on top of the mantle, which is supported by a convection process where you have hot rising from the center and cooling off at the top. And the crust is this collection of plates that sort of floats around on top of it. And as a result of them impacting each other, we get interesting land features, and we get volcanic activity and a variety of other things. And one of the natural things we want to do is go looking for that similar process, that idea of convection inside, volcanic activity at the surface, and other features that are associated with it. And both Tharsis Bulge and the volcanoes there, as well as the apparent potentially failed plate tectonics that is Valles Marineris, speaks to the story that Mars was in the process, or at least attempted, I'm personifying it, of course, attempted to have this more successful plate tectonics and a crust that floats around the surface. But for whatever reason, maybe Mars was too small, or didn't have the same kind of internal heating that Earth does. It cooled off and quote unquote froze out, so that the warmth inside stopped, and whatever plate tectonics had tried to begin did not work, and that gives us Valles Marineris, as well as the volcanic activity all died away. So there's a whole rich history there of what Mars was doing billions of years ago.
And definitely, and I think this is actually a great one to show here for the sort of the difference between Earth and Mars. And say, oh, Mars is only half the size of Earth, but it's actually 0.1 the mass. So it's got a lot less material there. And if you think about it, if you had, if you're in Toronto like we are, and you have a little tiny jacket on in the middle of winter, you're going to cool down really, really fast, which is the thing I learned during my first winter in Toronto. It's get a big jacket, right? But planets need a jacket too. And what is their jacket? Their jacket is mass. And so if it has more mass, more rocky matter up there, it's kind of got a big coat on, and it can hold that heat in the center. And it's because it has a certain amount of heat that's generated, that heat can't get away easily. So you have this what's called an active core on Earth, which is great. It generates our magnetic field and protects our atmosphere and protects us. But Mars didn't have that. It was not massive enough, and it cooled down and radiated its heat away. And at some point, there was just no heat left inside. So it doesn't have any way of warming itself back up. It's just going to keep on cooling down for the lifetime of the universe, as it were. Now, we have, of course, a lot of different things going on with Mars, of course, and with Mars's atmosphere, Mars's mass. Now, there's a couple questions, I think, appearing in chat, just trying to keep a little bit of an eye on it, but water on Mars. So there is a lot of water on Mars, and we have actually a bunch of different fun things for water on Mars here. There's lots of different forms of water. So we have, of course, water subsurface, water under the poles, water in ice. We don't have water flowing on the surface. So I think we had Quinton, you were going to go first, was it? And you were going to look at a little bit about this news, which might be actually driving some of the questions. The news item for like the last couple of weeks or so about the lakes under the poles of Mars.
Yeah, this is really exciting news. So in 2018, an Italian team of researchers announced evidence of salt water beneath the southern polar cap of Mars. The radar sounder of the ESA Mars Express orbiter had detected unusually bright, reflective patches below the ice. This, the researchers argued, could be a lake of liquid water 12 miles or 20 kilometers across that melted from the ice cap and was trapped beneath it, over a kilometer beneath its surface. On Earth, similar lakes form beneath glaciers, where heat from the ground and the pressure of the glacier above melt some of its ice. And although Mars is too cold for pure water to remain in liquid form below its glaciers, it could do so if it were extremely salty, with a much lower freezing point. This briny mixture might be filled with salts called perchlorates, dissolved from rocks. But it wasn't a slam dunk case. Mars is not very geologically active, and it's not clear whether the planet's interior can supply the amount of heat necessary to create a lake of that size. Now, scientists are back with a new study published September 28th in Nature Astronomy that they say bolsters their argument. They use data from the Mars Express radar sounder called MARSIS, Mars Advanced Radar for Subsurface and Ionospheric Sounding, and analyzed a data set of 134 radar profiles compared to 29 in their previous study. They also brought a new approach, adapting radar techniques used by satellites orbiting Earth to image buried geological features. Their analysis looks not just at how bright an area is, but other metrics as well, such as how the signal strength varies, including how smooth the reflecting surface is. Previously, this method has found subglacial lakes in our own Canadian Arctic. The interpretation that best reconciles all the available evidence is that the high-intensity reflections from Mars are indeed coming from extended pools of liquid water. There's not enough heat at these depths to melt the ice, so scientists believe the liquid water must contain high concentrations of dissolved salts. These chemical salts, different to the stuff we sprinkle on our chips, can significantly lower water's freezing point. In fact, recent experiments have shown that water with dissolved salts of magnesium and calcium perchlorate, a chemical compound containing chlorine bound to 4 oxygens, can remain liquid at temperatures of negative 123 degrees Celsius. Very, very cold. So we do believe that there is liquid water of a sort on Mars. It's buried deep underneath the glaciers, and it is much, much, much too salty to drink without any sort of treatment. But
yes,
all evidence does indicate it's there. So that's very exciting news.
Yeah, it is exactly. And this is it's worth mentioning is it's because this is water on another planet. It can be very different from what we think of. And it's worth remembering here on Earth, even we have things like the Dead Sea, which is just saltier than anything else. It's incredibly high density. You can just about walk on it. I mean, not actually, but it's a very, 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 very salty body of water. This is so much more concentrated than that. It's what they call super saturated. It's literally got as many salts and things in it as it could possibly have. So water on Mars is a little bit, shall we say, like everything else, it's a little bit over the top. So let me just hop over here. It looks like our live image, we have actually gone ahead and set it up with the other camera. So thanks to Professor Delaney and Anna for doing that for us. So we're actually going to just show you really quickly the live view through the CCD camera. So I mentioned before that we have 2 cameras on here. One is the eyepiece and the other is the CCD. The CCD camera has a little bit of an advantage over the eyepiece cam because it actually exposes light into sort of little buckets that then get exposed every certain amount of minutes. So we can set a defined exposure time, in this case just 1 second. We're using something called a neutral density filter to block a huge amount of the light, because it is, as I say, brighter than Jupiter. So it would actually damage our CCD if we let all the light through. But this, we can get a little bit of a better view of the features because they're not jumping around in real time. It's light coming in, hitting our device, and then going through to the camera where it's processed. So this is let's see. I'll go ahead and say that this does show the albedo regions a bit more clearly. The keen-eyed amongst you will note that in this case, the bright region is on top. This is because there is an extra mirror in the way, which has sort of flipped the image around from the eyepiece cam. So we've got our bright region has been flipped around on top, our bright albedo region, and that's where Amazonas is. And our two dark Serenium and Cimmerium are kind of creating this band around the equator, and that's roughly where we would expect as well, of course, the Valles Marineris that we talked about earlier, and the Olympus Mons would be just up here in this bright region, which you can kind of see. Okay, so a little bit of a better view, a little bit higher feature distinguishing, shall we say. And if you can just get a little bit of a glimpse, I'll just give a little shout out to in this darker region here, as we go what looks to be the bottom part of the image, that would just be leading on to the utopia area. So if you've ever heard of in sci-fi, they like to build spaceports in utopia on Mars. So I'm not sure why, but this has happened in at least 2 different sci-fi shows. But it's quite an interesting area here. So we are getting a little bit better views, and you may notice that that it's maybe just in a slightly different position than it was before, due to our rotation, and of course Mars's rotation as well. Now let's see here. That was Obada, you just did 20, so I think Sunna, you were next. So we're going to go ahead and hop over to Sunna, who wants to talk a little bit more about Mars's poles.
Yes. So the polar regions of Mars are also very interesting areas, which do have some water ice. So they're not liquid, but they're in the form of ice. So the North Pole, which is the Planium Boreum, is home to a permanent water ice cap and also a seasonal dry carbon dioxide ice cap, which sits on top of the water ice during Martian winters. The water ice cap can reach up to 3 kilometers in depth at some point, so it's very, very thick. The North Pole also has another canyon, which is comparable in size to the Grand Canyon, called the Chasma Boreale. The image on the left shows the ice cap and also dust storms around Planium Boreum and was taken by the Mars Global Surveyor. The image on the right is a more detailed image of the North Pole water ice cap, with Mars's South Pole, Planium Australe, also has some very interesting features. This is a permanent water and carbon dioxide ice cap, which is approximately 3 kilometers thick, and recent observations by the European Space Agency's Mars Express orbiter indicate the presence of saltwater lakes under the southern ice cap.
Indeed, and it was those same saltwater lakes that we were talking about before. And it's worth noting that this has been theorized for quite a while. People have been saying that they think, it could be possible to have some sort of lakes or bodies of water underneath the poles because of their composition, and there might still be some sort of residual heat left underneath the surface to help warm it up. Now, all science fiction aside, it has taken a little while to actually be able to resolve these because it is subsurface. So that's why we were using the radar before. And these lakes that we're finding, so far it is the southern polar cap that has mostly been mapped out, but the northern polar cap is not completely ruled out, shall we say. Jesse, you have a little something to add?
Yeah, the data from Marsus, which is on Mars Express, that is about these lakes in the southern poles is real. It's really interesting how they got it, because when they first devised this experiment, they were actually trying to do this much earlier than 2018, which is the original published date that Quinton mentioned a little bit ago. When they were at first attempting to do it, they did the radar soundings. You bounce radar off the surface and you look for weird reflections, and hoping that, and then you can attribute the reflections to liquid underneath the ice. But when they first did it, all of the results were very weird, and they found that that the data that they had wasn't detailed enough, because the reason, the real unfrustrating reason, was because the radar images that were being taken were compressed on board the Mars Express. The Mars Express had software built in that would take the images and then compress them, because putting data back to Earth is expensive. It takes time. And so they were immediately compressed, and the researchers realized that they needed the full raw data in order to actually say for sure whether or not these radar soundings were indicating water or not. Luckily, there was an extra couple of ports that were open on Mars Express before launch that were filled at random with RAM, extra RAM, that nobody seemed to be using. So there was this, and get this, there was 16 megabytes of extra RAM on board. Now, this Mars Express was launched back in 2003. How much RAM was in your computer in 2003? Well, an extra 16 megabytes was enough. They able to go in and program Mars Express a little bit to allow it to use that extra 16 megabytes of RAM in order to take more detailed images, not compress them, and send the full raw data back to Earth, so that in 2018, they were able to publish that cool work on the lakes under the South Pole ice cap. So there's a really interesting story there on how engineers are probably some of the most ingenious people on the planet, working on things off the planet.
Absolutely. It's another great victory. And since you mentioned it, I'll just say, it's another great example of weird findings in science being actually very, very useful. So as they say, it's not necessarily a eureka moment, but that's weird. That really leads you to some interesting discoveries. All righty. Next up, we have a cat who's going to tell us a little bit more about not just, it's not just all about, lakes and ice. There is actually clouds as well.
Indeed. So we denote that as the white cloud. So with the help of the Mars Express orbiter and its visual monitoring camera, astronomers at the European Space Agency have spotted the return of a mysterious cloud on the red planet on July 30th, 2020, so that's not too far away. So the long, narrow cloud of water ice was observed on the leeward side of Arsia Mons, the large volcano near Mars's equator. So Mars Express captured images of the recurring feature in mid-July. This elongated cloud forms every Martian year during this season around the southern solstice and repeats for 80 days or even more, following a rapid daily cycle. Astronomer Jorge Hernandez Bernal said that in an ESA news release, rather. Scientists on the project recently named the planet's most prominent cloud the Arsia Mons Elongated Cloud, or AMEC for short. Though Mars's atmosphere is much thinner than Earth's, the red planet regularly hosts cloud formations. Studying Martian clouds can help scientists better understand Mars' climate and seasonal weather patterns. Like Earth, Mars has equinox and solstice periods, but due to Mars's larger tilt, the seasons are more extreme. Early in the morning, during the southern solstice, long, wispy clouds like AMEC often form, growing quickly before disappearing by afternoon. Most orbiters snap photos of Mars in the afternoon, but Mars Express does its observing in the morning, when southern clouds are more likely to appear. Luckily for Mars Express, the highly elliptical orbit of the spacecraft, coupled with the wide field, of view of the VMC instrument, lets us take pictures of covering a wide area of the planet in the early morning. So Mars Express has previously used its near-infrared mapping spectrometer, or OMEGA, to image AMEC in September of... Sorry, gotta get the date correct. I lost it.
2018, I think.
Yes, June and July of 2018. Thank you.
Yeah, it's been another long project of imaging, and this very interesting little feature of Mars's atmosphere. So just go ahead and give a little shout out, of course, to Mars's very unappreciated atmosphere. Mars gets a lot of, shall we say, flack for not having much in the way of an atmosphere, but it does have clouds, it does have weather, and we could actually get clouded out from the other side. So it is, I'll just go ahead and put up an extra image here of clouds. Kat, did you have any other things to add about the white cloud here before we hop over to Mars image?
I do believe that we have covered everything for the white cloud.
Excellent. All right. So this little white cloud was very interestingly, reoccurring. So it is thought to be somewhat seasonal from our, not a huge amount of observations, but it does kind of fit in with what we know about possible outgassing of Mars, and, the different rather extreme seasons of Mars. So if I just hop back, actually, I can put up one of these pictures. So this is what I like to just put up just to say, we talk a lot about clouds on Earth and we complain about the seeing, but we can have clouds on Mars. So it's not just dust storms and dryness. Mars's atmosphere can get lots of different clouds above it. Actually, if you look up some of the high-rise imaging around Olympus Mons in particular, you can find big fluffy clouds sort of parking on the mountaintop, just like they do here on Earth. Now, Mars, this is a nice little set of two images, cloudy Mars versus an uncloudy Mars. So you can kind of see what it looks like when it is clouded over a bit. The clouds are kind of very thin and wispy looking. Tends to be carbon dioxide types of clouds, right? So the atmosphere is primarily carbon dioxide anyways. And you might have a few little clouds moving in. And this is just also helps identify some of those albedo features that we were seeing kind of at different angles before. And we are still getting Mars coming in. So I will actually just put that up here really quick as well. Just shifting back to our eyepiece cam to bring in the color. And you can see that the seeing has improved a little bit. And the one thing we don't see is any hazy whiteness from clouds. So we, at least if we have to have clouds here on Earth, we do not appear to be clouded over on Mars itself, which is kind of a nice little, we only have to deal with clouds on one planet, which is always a good one. All right, so as you can see, this is the live eyepiece cam. It's just jumping a little bit, not quite as much as before, but again, those dark regions, the albedo features, they have shifted just a little bit. So again, as I say, we'll keep checking back on it, and you should be able to make out more and more. But I will put this up really quick because I have the distinct impression that I'm definitely able to detect the utopia region. So if you please just flip this picture around in your minds, so that we can actually, wait a minute, I can invert the view. Mirror reversed north and east, west and north. Let me try this. I'm going to try to invert the view here. I'm not sure if it'll work. So I do have a little bit of an inverted view. I think this is about right. So this is a slight, so all I've done is I've just used the Mars profiler to turn it around a bit. So the utopia region, this albedo feature on top, should kind of be this top part of Mars. And then we're getting Mare, Serenium, and Mare, Samarium going across with the bright feature below. And I can't get a straight up inversion, so I think we'll go back to this one because this gives more of a correct position for Amazonas. But this, if you can kind of see that dark feature up in top, that was definitely Utopia. So the pole would be actually just on top of that if we can bring it out later. All right, so Mars is still up in the sky. And we are still watching it live going past. So this is, of course, Opposition 2020. Hope you're all having as much fun as we are. As I said, technically we could follow this all the way until sunrise, although we will have to stop at 10 because some of us have to get up in the morning, unfortunately. All right. Now, next up, we have Obada. You're going to tell us a little bit more about Mars here.
So yeah, as mentioned earlier, Mars has many interesting features. Some include the vast valleys and canyons, indicating the fact that liquid water once ran through them. Despite it currently being a dry wasteland, we have significant evidence that Mars has plenty of liquid water and that is now been sublimated or frozen under the surface. The most obvious point is the polar ice caps on the poles of Mars. These ice caps are composed of both dry ice and water ice. Some previous missions to Mars were also able to detect snow, yes, snow, in the upper regions of the atmosphere. Although it isn't anything like the snow here in Toronto, it's still a very interesting and significant discovery. In addition to all of this, ice is easily found in many regions buried under the Martian sand. This could be very useful to future astronauts who are not going to be carrying their own water supply. So in conclusion, there's plenty of water on Mars.
Indeed, it's not just all sand and dryness. We've got water all over. I think it is one of the things that has made a bit of a turnaround historically. Mars kind of went from being very promising to not very promising to interesting, but definitely has water, which is I think where we are right now. Lots of different forms of water in terms of ice and outgassing and now lakes on the pole. So you got, all kinds of great things happening. And I'll just give a little shout out to any folks joining us live as well. If you are live on YouTube now, you can ask us questions in the chat. And if we're able to, we will answer as many of those as we can, sort of going on to 10 o'clock tonight. Okay, very nice. Thank you for that, Obada. And let's hop over, and Kat, you were next to actually talk a little bit about our own observatory's connection to Mars.
Indeed. So I'll be talking about Professor Emeritus Allan I Carswell, who on September 14th, 2017, donated $500,000, matched by York U's Faculty of Science, to purchase a new 1-meter telescope that puts the price at a grand total of $1 million. The observatory was renamed to honor this donation, and in August of 2019, the telescope was installed. Where is our Mars connection? Well, in fact, Allan I Carswell served as co-investigator of the Mad Dog LiDAR instrument accepted by NASA for inclusion in the 2003 Mars lander mission. Although this mission was aborted, the LiDAR instrument development work continued as part of the NASA and CSA supported Matador program. His expertise with LiDAR led to the invitation from NASA to include a Canadian LiDAR on Phoenix, the NASA 2007 mission to Mars. Dr. Carswell served as co-investigator meteorology for the Phoenix mission and led the development of the first LiDAR on Mars for studies of the Martian atmosphere. This LiDAR discovered the existence of snowfall on Mars, a previously known component of the Martian hydrological cycle. In recognition of their seminal contribution to this mission, Allan, along with his wife Helen and other members of the Phoenix mission, have their names engraved on a silicone mini DVD on the Phoenix spacecraft remaining on the surface of Mars. So, in a small way, our observatory is also on the red planet.
Indeed. So it is, it is nice to have that Mars connection, especially the Phoenix connection. It was actually the first laptop sticker I ever got was a Phoenix mission laptop sticker. So I was quite floored when they told me that it was actually the Phoenix mission that was involved here. It's actually related to ice as well. It was a part of the sort of the ongoing discovery of ice and water on Mars. And yeah, the fact that Allan I Carswell, it's the name of our observatory, but it's also the name of a person who is had their name engraved permanently on Mars, which will be there forever, as far as we can tell. So in a way, it's kind of a we're I suppose our namesake is the right way to say that. But it's good fun, good fun. All right. So now we've got a little bit of history, as it were, and a little bit of an extra introduction into into what's going on with our observatory and our secret Mars connection. So I'll just hop back, and since we've been talking about water quite a lot, it would be actually great to have Quinton. Can you hop in and give a chat about some of the surfaces and resurfacing on Mars?
Certainly. Mars has a very interesting surface. Parts of it up here are very cratered and pockmarked, while one part of the surface, blue in this picture, seems to have fewer craters. In the solar system, the more craters a surface has, the older it is thought to be. That is because activity like water, wind, and other geology moves and pushes surfaces, destroying craters. At some point in the past, Mars had enough water on its surface to form a lake, erasing many craters in one area. Although we cannot see the lake anymore, we can see where it used to be by looking for the least cratered area. So this is yet more evidence that Mars used to have an abundance of water, much like the Earth does now.
Indeed, and there was a question actually in chat earlier about lava, and this actually sort of pertains to what we call sort of the active period of Mars's surface. It's in its early history, it had a lot more heat, and one of the ways that that heat manifested, of course, was lava and some of the lava rocks that we still see on the surface of Mars today. Another way that the heat of Mars, helped out in a way is to, of course, melt water and cause there to be large amounts of liquid water on the surface. So in the past, Mars would have had active volcanoes, it would have had lava, it would have had water, it would have had a thicker atmosphere. So you could understand why people have always been a little bit entranced by this, what is now actually quite close by planet. All of that has, as they say, sort of died down, but it hasn't really disappeared. So the volcanic rocks can still be seen. The water appears to be mostly subsurface, but it's certainly not disappeared. Wind erosion is still taking place all of the time. Um, all right. Looks like a very, very fun. And we'll just go ahead and show, since we've been talking about the water, I am also, of course, just going to talk very, very quickly about the one of the first water mappings that was actually done of Mars. People realized pretty quickly that Mars would have to have subsurface water if it was there at all, because the conditions on the surface basically meant that even if water wasn't ice, most places it would just directly what they call sublimate. So it sort of directly transitions into a gas, gets up into the atmosphere, and of course Mars doesn't have enough gravity to hold on to it, so it quickly just sort of disperses off into space and would be lost. So you wouldn't have water able to survive on the surface for any really long amount of time. But this map in particular, it was, as I say, actually, we were talking about the Phoenix mission. I believe this was done, I'm a little bit remembering, back in the day, but I believe this map came out either just before or after the Phoenix mission. And it was attempting to measure the amount of water underneath the surface, and of course, we now know that the poles have been mapped with radar, with those lakes. But what about just looking for hydrogen? And so what they're looking for is hydrogen abundance or overabundance, because if you have water, you have H2O, which is hydrogen and oxygen. So if you have a hydrogen abundance, you could link that to water. And that's exactly what the neutron spectrometer tried to do on the Mars Odyssey. So 2002 to 2003. And they made this map kind of showing where there was evidence for subsurface water. So because of the hydrogen abundance, they were able to say, look, there's definitely signs that underneath the first, what is it, about a kilometer or so, there's probably some form of water. And so you can see it's red up at the tops and the bottoms. That is the poles. But actually, around the equator, there are some fairly large regions that seem to have, I don't know, some form of water either embedded in the surface or just below the surface. So it would be very, very interesting to be able to map that in a little more detail with, say, I don't know, an expeditionary crew or something like that. If you can tell on the image here to the left in the blue region, we have actually, that's the Valles Marineris, the great big canyon that came up before. Not so much water there, which is kind of as we expect. We think that it was kind of a tectonic crack and not a water-driven feature. So unlike the Grand Canyon, which was sort of carved by water, the Valles Marineris might have been more of a pure tectonic activity, shall we say. Now, we just had one extra question come in, so we'll go ahead and take that now. Caitlin would like to know when we will have technology to maintain a habitable settlement on Mars, which is an excellent question. Actually, there was a fairly famous book that came out, written in, I believe, the 60s or 70s, called A Case for Mars by Robert Zubrin, which actually made the case that we already have the technology to maintain a settlement on Mars that would be habitable. And it went through the various technologies that you would need. Of course, you have to be able to make water, you have to be able to grow food, you have to be able to have protection from the dangerous radiation on coming in from the sun, because there's no magnetic field. So what would you need? And I walked through all of the different ways we could do that with the technology of, I believe, maybe the 70s or 80s, 1980s. So now, of course, we have a lot more technology, but we're still not quite on Mars, because people have been trying to be a little bit, I suppose, more safety oriented about it, but also there hasn't been a lot of interest from large corporations and companies to go there until, well, fairly recently. So it's quite a big endeavor. You wouldn't be able to do it if you were just one person. There's a bunch of different, things about settling on Mars. Of course, various people have come up with various types of settlement ideas. The original case for Mars, basically from Robert Zubrin, said that we could do this for relatively cheaply, just $1 billion or so. It'll be fine. You set it up and you make it as a self-sustaining colony that's there forever, and you set it up as a place to last. So you don't send people there for visits, you send them to live there, and they'll build up your settlement, kind of a little bit of the old Wild West, if you will. Now, since then, there were quite a few other estimates as well. Some people were saying, it'll be, $100 billion or more, and it's impossible unless you do all this other stuff. But it's worth keeping in mind that if you were of an entrepreneurial spirit and you had access to a spacecraft, you could just go there. You would have to set yourself up, of course, with quite a bit of initial supplies until your well, we haven't talked about the movie The Martian, but your potato crops came in anyways. Now, Jesse, I believe you had a little bit about this one as well.
I was just thinking, I think you mentioned it. So I read The Case for Mars as well, and that is a fantastic book. And you see notes of it in movies like The Martian, which is really cool, and or books like The Martian that later became a movie. But I was just there were estimates made of, in that book that Zubrin wrote about how much it would cost at the time. So it's billions of dollars, which is not that much. I mean, if you want to fly and colonize a place like Mars, then you'd think it could be money that you not even all of the countries on Earth have. You could imagine that it could be that exorbitant, but the book laid it out and said, here's the technology, here's the plan, this is how much it would cost. You just need political investment and monetary investment. And at the time, that wasn't, when that book was written, it just wasn't going to happen. It's getting closer to the time now that it could happen. But I do like what you say is that we do have the technology. It is here. It's about how we do it and who's involved really right now.
Exactly, and it's always a case of like, if you think about it, people say, well, okay, it's a little bit like the early days of sailing, and people trying to navigate the Earth with sailing technology back in the day, and there's like, okay, well, what do you need to sail around the world? Well, do you need a cruise ship, or would you be able to do it with a small boat that you could build yourself by hand? And the answer is, well, humans are fairly ingenuitive. So if we can find a way to make it such that technology does become available more widely, there have been historical reenactments where people have done trips, not all the way around the world, but certainly from Europe to North America and from Africa to South America, on some very, very small, handmade crafts, just to see that they could do it. And yes, you can do it that way, and it'll be fast, and you'll have it done, and you'll be there. Or you can, first build an iron refinery, and then, you build a processing plant, and then you build a giant steamboat, and, you build up this entire large construct, and then you sail yourself across in some sort of, not the Titanic, but one of the ones that didn't sink, a large boats. And it's both of those ways would get you across the ocean. But when you tell people what's the technology that I need, it's not necessarily the minimum technology that you could just go. If you've got a rocket and you've got enough oxygen, you could go. Now, of course, astronauts being astronaut positions and rockets being somewhat expensive right now, it's still quite hard for an individual person to say, oh, I'm just going to go build a house on Mars. But that won't stop some of us from thinking about possible locations and where we might go to for our vacation houses. So I of course have Hellas Basin mapped out. I think Kat, you you had a similar location earlier, and yes, you could build a settlement there. You could put down, of course, on Mars. If you dig down into the surface, this is something that's been brought up quite a lot. If you did use rock as shielding, all you'd have to do is to build your Mars house underneath a few meters of rock or soil to protect yourself from that radiation, and you'd kind of have a little bunker where you were sort of protected from radiation. You would also have lower pressure or higher air pressure, lower altitude, all kinds of fun things like that. It is worth noting. It's a little bit relative. At the moment, the hardest part for all of us is actually getting off of the planet. The difficulty in getting off of the surface of Earth should not be underestimated. I've always been kind of a fan of the old proposals for making magnetic rail launchers. I know they're not technically survivable for humans, but if you had a way to easily launch things and people into space, it would be so much easier to have spacecraft and to go places. So there's all kinds of great ways, but yes, wonderful question. We could probably talk about this one for ages. And as you can see, Mars here is just absolutely shining in the background through the eyepiece cam. So I just put that up to run while we were discussing going there. If we did launch right now, one of the first things we'd see as we left the atmosphere of Earth was all of a sudden this image would stop jumping around, and that would it would actually become very, very, very clear. So this is one of the reasons why we love to launch our telescopes into space, is to avoid this sort of jumpy behavior that the light has to pass through our atmosphere and whatever turbulence and clouds are in the way. Quentin, would you like to make a plug for the space elevator?
Yeah, I was just talking about how even though it's a bit of a even though it's an absolutely even though it's an absolute logistical nightmare, and there's a lot more complications to it than initially there might appear to be. The space elevator is, at the very least, a really interesting and cool idea. Essentially, what it is you launch some sort of counterweight up into geostationary orbit, so that it remains above the same point on the surface of the Earth, and you have some sort of winch or cable system that connects that to the surface of the Earth. And then, rather than try to launch any objects out of Earth's gravitational well from the surface of the Earth, you carry them up this elevator and launch them from orbit. So one of the advantages to this is, one, you save a lot of fuel because you don't need to you don't need to use fuel to transport all that mass up there in the first place. You only have to spend the amount of fuel to escape from the comparatively weaker gravitational pull at that level. And second of all, you could actually use the fact that the space elevator is in geostationary orbit to kind of help propel you. Since it would have to rotate with the Earth, you can use that extra angular momentum to give yourself a bit of a boost and get and move further forward. This is the same reason why almost every space center on Earth launches in the same direction that the Earth rotates, because it allows it essentially gives a bit of a boost to the rockets, allowing it to be a little bit easier to escape from Earth's pull. Unfortunately, the dream is not quite as simple as it seems. For example, you can't just have that object stay up there indefinitely as you move things up and down the elevator, because, of course, momentum is always conserved. So as you try to transfer mass up the elevator, there's going to be an equal and opposite force on the counterweight itself, which is going to cause it to want to move closer to the Earth. And that effect may not be so severe for the first couple uses, but over time it is going to add up. So you need to have something like retro rockets on the elevator itself. And of course, then you need fuel for them. So it is unfortunately not quite as simple as it initially seems, but it's still something that I think is really, really fascinating. And I kind of wish that we learned about it more, because I didn't find out about the idea of a space elevator until comparatively recently, whereas I've known about rockets forever. And I kind of assumed that rocket technology was the only way that could ever exist to get people into space. So I just wish that there was a bit more of a conversation about it.
Oh yeah. Well, and if you read this is what science fiction is really good for. And the first one of the first science fiction movies ever made was actually the Journey to the Moon, where they actually just used a straight up gun to shoot themselves into space, which is, a very alternative approach. Don't try this at home, kids. So I've just put up a little picture of the sky right now, just in case any of the viewers watching live would like to try to find Mars in the sky right now. It has just risen from the east and is on its way across. So if you are looking east southeast, shall we say, it will be that very, very bright red object just a few degrees above your horizon as you're looking towards it if you're in Toronto right now. So you will be able to see that. And of course, a little shout out as well to the the elevator concept, which is in the science fiction novel Red Mars. And Mars would be a better place for a space elevator for the exact reasons that Quinton mentioned. It would actually, because of its lower mass, it is actually a little bit easier to keep a space elevator running, and it does have 2 captured asteroids already in orbit. So unlike Earth's moon, they're not super, super far away, and you could, in theory, which is what they do in the book, use one of them to tether a space elevator, which would be pretty cool. Now, let's see here. We have a quick, we are getting a little bit of haze coming through on Mars itself. So I'm just going to hop back over to our main area here. And Sunna, you had a little bit of rocky facts for us about Mars.
Yes, so just a little bit about Martian rocks. One thing that's really cool about the rocks on Mars is that the most common kinds of rocks are due to ancient volcanoes. So Mars has lava rocks, which is pretty cool. So these lava rocks on Mars, not only they'll actually go and interact with other environmental features like water and wind, and they form some other interesting kinds of rocks and minerals that we can explore. So in particular, mineral deposits formed by lava heated water containing salts, sedimentary rocks deposited from volcanoes or erosion, igneous rocks, which is your typical lava rock that's cooled down, cooled solid lava, and finally metamorphic, which is sedimentary or igneous rock transformed by high pressure or heat, usually from volcanic activity.
Indeed. And here's your igneous.
Yes, so then there's a special shout out to igneous rocks, which are these jagged, hard rocks that are produced when lava rocks that I just talked about, when those cool down. These rocks change depending on the lava or magma they were formed from. So depending on their origins, they will have different amounts of things like quartz and different types of feldspar crystals.
Indeed, and these rocks actually are quite amazing in terms of allowing us to map them on the surface of Mars, because they retain heat quite well, and during the daytime they get heated by the sun, and at night they emit an infrared. So infrared cameras on Mars have a wonderful time with these rocks and mapping them. It was actually one of my favorite projects during undergrad, was getting to use some images from infrared cameras and process them of features on Mars, because you can really see where the igneous and basaltic rocks are. Very, very nice. So I'm just going to put up Mars one more time here. We're just hopping in and out of the clouds, but as I mentioned at the beginning of the night, if you look carefully at the features of Mars and ignore the wobbliness of the planet, you will see that it has shifted just a little bit since the beginning. If we were to watch this all the way until sunrise, we would see it move quite a bit more. So let me just reset this. This is my Mars profiler I'm putting up on the side. So that's my sky and telescope Mars profiler. And we're just running into a smidge of clouds here. So I think we'll have to go off of memory. Let me just see how it's going there. And looks like we just have a bit of clouds blocking our view right now. Oh, there it comes again. So we can see that it has moved. The Mara are in slightly different positions, and Syrtis Major has just started to make an appearance on the edge of Mars. So that's just coming through on the side there at the moment. So we can see a little bit more detail, and as it fluctuates in and out, you can also see that the Utopia region at the top, or at the bottom here at the top in our image, really does kind of look like a line at some points. So you do get a little bit of a of course, that the discussion of lines and canals on Mars, and just on the limb there, that is Syrtis Major poking through for the first time. So it was completely hidden before. And if we could stay up really, really late tonight, if I go ahead and add a couple hours to this map, I just need 2 more hours and Syrtis Major will rotate back all the way around front. Of course, providing that the clouds don't keep blocking it. Alrighty. Now let me just go ahead and pull up our Mars fun slides. Now there is a couple extra things about Mars that we can of course talk about tonight to round off, but there's nothing quite as fun as, of course, sci-fi on Mars. So I just have to give a little bit of a shout out to if there's any other questions in chat, we'll take those. But if not, I'm just going to give a shout out to a little bit of our favorite sci-fis. And one I always have to mention is, of course, Mars Attacks. This is probably one of the arguably the funniest Mars fiction movie. But it is gosh, what was it, 2000 and something? Mars Attacks had Martians, or fictional Martians, which arrived on Earth. And I'm just going to go ahead and say, if you don't want a spoiler for this movie, just skip the next about 65 seconds of the video. So spoiler alert, Mars Attacks is not a particularly new movie, so I'm not super worried about spoiling it for anyone, but it is quite fun. And the Martians are battled. It was actually a 1996 movie with a particular kind of sound. So one fun thing to think about is air on Mars is so much thinner than air on Earth. Sound waves actually would propagate differently. So if you were somehow to move to Mars and to adapt to life there, you might be more sensitive to certain kinds of sounds were you then to come back to Earth. So that was it's actually a really good song they play in the movie too. So it is quite fun, and I always have to include this one because this is actually one of my mom's favorite movies as well. It is interesting that in the movie, the Martians are quite short, petite creatures. But Mars has such low gravity. If you were to go there, you would naturally start to lengthen. Your skeleton would start to lengthen a bit. And this happens to astronauts in space as well, because there's no gravity. So your body actually stretches out if you go to the space station for long enough. So astronauts actually have to adjust as their skeleton sort of clinks up and stretches them out a bit. So one thing I always wonder about this one is why are the Martians so short? Shouldn't they be super, super tall with the low gravity of Mars? So I mean, obviously that's not the most unrealistic part of this particular work of fiction, but it is quite fun to think about. And as well, we have a little shout out for War of the Worlds. Quinton, this is one of your favorites.
Yeah, certainly. War of the Worlds was one of the first. Well, it wasn't one of the first sci-fi works, but it was certainly one of the ones that really introduced the concept of an alien invasion into popular culture. And this was actually inspired by the theory that had been going around at the time about the canals on the Martian surface, which we now know do not exist. Possibly the most famous thing about War of the Worlds is that the book was adapted into a radio drama, and that radio drama kind of grew to be rather infamous because it was presented as if the narrator were a newscaster announcing the details of an alien invasion. And people who started listening to the radio drama after it started and didn't catch the introduction where they said that it was a work of fiction thought that it was real. They thought that there were actual aliens invading the world, and it caused quite a bit of mass hysteria and panic before people realized what was actually going on. So for that reason, if for no other reason, it's an absolutely remarkable work. And of course, it had a significant amount of influence in pop culture. I don't believe that we would have nearly the level of fiction that we do about aliens invading had it not been for this piece of literature.
Indeed, and it's been analyzed many times since. I believe there is some discussion still as to, how many what percentage of people actually did actually did panic, and they said something like, they thought it perhaps might be a percentage, a fraction of a percentage of 1 in a million. So there's a little bit of debate as to how many people actually did panic, but it was not a good look, because even so, still you want to make very, very clear that it's was it a panic or was it hyped up hysteria? There is some debate on it even to this day. Now we are running out of a little bit of time here, so let me just go ahead and pull up our comparison from Jesse. Thanks for putting this up, Jesse. But this is just from tonight. So it's a little bit of spot the difference over 1 hour. It was a little blurry. So you can see that it has shifted a bit, but maybe it's not quite as I'm not sure we picked up the closest the clearest parts of Mars's features. You can see on the second image we do have a little bit more of Syrtis Major. And just to round us off, I will hop back over. We are getting quite a few more clouds now than we did at the start. So I'm very, very pleased that we were able to show you images all throughout the night here, because of course, with live images and live viewing, we always run the risk of course, clouding out. So at least we got to show you some of them. All right. Any last greetings from anyone on our crew? Let's make a last call for Mars fun facts. And I think we should probably wrap up here a little bit. Let me just check this. And yep, it is in fact 10 o'clock. So it's not the witching hour, but it is probably time for most of us to start wrapping up and going home. So I'd just like to go ahead and put up a little outro here. Thank you, everyone. You have been listening to the Allan I Carswell Observatory's special Mars Opposition 2020 Teletube broadcast for this, the opposition of Mars. This is the official Mars opposition on the 13th of October 2020. These broadcasts are presented by astronomy and astrophysics students, faculty, alumni, and friends at York University, and are part of our, or say, a spin-off from our regular Wednesday Teletube broadcast. The slides for our show tonight were put together by the York Observatory 2020 Mars crew members, Kat, Gagan, Stanley, Obada, and Noah. Thank you for joining us on this exciting occasion. Make sure to leave any comments or questions in the comment section of the video in case we missed you during the chat. And you can always connect with us on Twitter or Instagram with the handle of @York Observatory, and on Facebook with the tag of Allan I Carswell Observatory. All of our programs are free, but if you'd like to make a donation, see our website at observatory.info.yorku.ca. Thanks for tuning in, clear skies, and have a great night.